All right, so let's get, okay, can you guys hear me? Okay, is that working? Okay, so let's get started. Yeah, thank you for sticking around. We're doing lunchtime. This is going to be 5 years of Teal, minimalism versus growth in language design. Oops, it's falling off. Let me grab this together. Okay, here we go. Okay, quick introductions. I'm Hisham. I've been doing free software for a long time, involved with many projects. I work at Kong, where we do free software like free open source API gateway, using mostly Lua. I'm currently working on the team that's adding WebAssembly support in Kong, and some of my other projects are Lua Rocks, Package Manager, Global Linux, the weirdest distro ever, and HTOP, the process monitor. So, but here I'm here to talk about like the project that I'm most recently excited about, which is Teal. Teal is a statically typed dialect of the Lua language, right? So if you know like what TypeScript is to JavaScript, you can think it's the same, right? Teal is to Lua what TypeScript is to JavaScript, but let's not go too far with that analogy, because here we're trying to keep to Lua's spirit, which is like a very minimal, a very tiny language, and like I don't have the backing of Microsoft and hundreds of developers working on as they do on TypeScript. But essentially we have a compiler, TL, that outputs Lua files. And so here's a quick taste of what Teal looks like. This is just like a random function I picked like from the source code of the latest version of Teal that I'm working on. And so what's lighter here like is what is not Lua, essentially the parts of Teal that are different from Lua. So we have a couple of different operators. You can add types there, but otherwise, as you can see, it's mostly regular Lua. I made the mistake of talking about Teal before without showing lots of source code, so this time I'm going to make sure I show source code. Teal is like the epitome of like conference-driven development, because when I first had the idea, I started like hacking it together, and like when I first presented it, like was the challenge like, can we do this, right? Can we add types while remaining minimal? And when I presented it back in 2019, like I was like halfway through, like the compiler still didn't compile itself, and I showed like, oh, I started with like 500 errors, and I'm currently at like 100 or something like that. But eventually I got it working, and then the next year I came back here and show it to you. And I said, like, minimalistic typed Lua is here, and there's this weird title because the language didn't have a name yet, right? So, and then eventually at the third part of the trilogy, we had a name, and we actually had users, and we had stuff going on with the language. And then I basically said that, well, now I think I'm going to let it settle for a bit, so that people can actually use it, because if the language keeps changing syntax like all the time and stuff like that, like people won't feel comfortable adopting it, right? So that's what's been going. Like we have like this small community. I always like to make a distinction between like a community and a user base, right? Because especially in the industry, people like to look at numbers. So whenever people ask me, how is it still going? Like, I tell them, like, oh, we're like 1.8K GitHub stars, which is like the vanity metric. Like, that doesn't really mean anything, right? But it means something, right? But in practice, when I think about a community, I think about the people who are involved with it. And then I could say, oh, there are, like, all of the other people who gotten involved, right? Because I'm just doing the source-to-source compiler, right? And then there's people doing the build system. There's people doing like the VS Code plugin, right? That gives like IDE autocomplete, those sorts of things. So nowadays, for a language, that's part of the whole package. That's what's expected of a modern language, right? So when I think of the two community, I think about like, I don't know, like 10 people or even less, right? But the people who regularly discuss on GitHub and all of that. So right, that's the community, right? Like the human aspect of it. And speaking of community feedback, here is like, this is a full screenshot of like all of like, if you go through all of the issues pages that are currently, like if you open the Teal GitHub repo right now, there's like 67 issues. Like these are all of them, right? And one thing I hate about GitHub is that they call everything issues. Right, so like feature requests, like back in the days of SourceForge, there were like separate pages for like bugs and feature requests, right? And now like calling a feature request a issue, I think it's like super weird. Like, I would like the program to do something that you did not design it to do. Now your code has issues, right? It's like, no. So basically what I do, I label all of them. Like, so the ones with the light labels here are feature requests. And the ones with like the darker labels, which are like the red ones, those are the bugs, right? So I currently have like 5 open bugs and like 3 pages of feature requests, right? And it's nice, like, sometimes you don't want to close your feature requests. You want to keep them around so that other people who have the same requests can see and comment on them, right? So basically, over time, you're just going to keep accumulating an endless list of feature requests. You're going to look at the repo, and one day we'll have like 200 open issues. Oh, this program must be all broken, right? No, it has a lot of people who are very interested in it. This is actually a sign of success. Like, people are interested in your program enough so that they are using it and asking for more stuff, right? So, yeah. So, but then once you have this many feature requests, like, and we're here talking about minimalism, how to keep the language small, right? I cannot add everything that people ask for, and this is like my hobby side project currently. I wouldn't have enough time even if I wanted to, right? But I don't want to, because I wanted to keep it small, keeping to the, like, that idea from the very first talk. Like, the challenge was how to keep it small, right? And the challenging thing is, like, I can't add everything that people ask for, or even everything that people contribute, because not only people go there and ask feature requests, some people actually send in features, like, all written like as pull requests. Like I would like Teal to do this extra thing, and here's the code to do it, please add it. And I go like, sorry, right? But it's super important feedback, right? So, yeah, but when you go back, like, it's always nice to look at that whole list and try to look at the big picture, right? And then I saw like 2 like very recurring themes on things that people were asking for, like, related about. Like, one is like nil safety, right? The famous billion-dollar mistake, right? As mentioned by Turing Award winner like Tony Hoare when he talked about this. Saying like adding the concept of null to a programming language was, back in the day, was his mistake, because like everything that came out of that afterwards. And Lua is another of those languages that does have like a nil type, right? And all of the consequences come with that. And the other one is that people keep asking for abilities to express more complex table types, because Lua is like the only single composite type that you have, like, apart from like integers, like numbers, booleans, like, and like tables, right? Which is a thing that doubles as a hash table and an array, right? Like, it's a thing with keys and values, and if you use numbers, it has like some special behaviors to make array access efficient, but otherwise just think of it as one big thing with keys and values. But once you start talking about types, you look like, oh, this table is really an object. This table is really a map. This table is really an array. This table is really a map, except when you use integer keys, then I want it to act as an array. Like, these are kind of things that Lua programmers do all the time, because once you have a table that accepts everything, right, you start having these composite types and all these weird things. But then people mix it up, right, and those are the bugs that people run into when they're coding in Lua with no explicit typing, and they would like Teal to help them with that, right? So let's talk about the first one a little. So as I was mentioning, like, given that every variable can accept nil, and you can pass stuff around like that, in Teal, basically every type includes nil as a possible value, right? If you declare a variable as integer, you can still put nil in there. Like, essentially every variable is like optional, right, in that sense. So this has some consequences, right? This makes, for example, that in Lua, like, you declare a function to have like 3 arguments. You can just pass 1 argument or no arguments, and like the Lua VM will accept it. And people do that on purpose, because essentially they mean like, oh, in the semantics of my application, that argument is optional, right? So Lua accepts that, and because Lua accepts that, Teal accepts that, right? And another side effect is that in table, like, missing keys are valid, right? So people, let's say you define a function that operates on a table that has like X and Y fields, right? But then in your program, since you designed that function that just wants to take something that takes x and y, you want to pass other things, right, that have extra fields, and sometimes they don't, right? So it gets really messy, right? So in one of the previous talks, I mentioned about like that I started looking at like doing the whole thing about implementing like nullability checks into the variables, and how like, and I showed like the size of the Teal compiler source code versus the size of like all of the code to do proper reachability tests for null variables and everything, and make like the whole check super automatic, and it started to get like bigger than the compiler itself. So that was sort of like a complete but heavyweight solution, right? So a very lightweight solution, or I would say lighter weight solution, like then actually having the proper optional types that people really want, right, was to have just arity checks, which is like how many things you actually put inside the parentheses when calling a function, right? So, and yes, if eventually we find like a lightweight way to like nicely do optional types, this will become sort of a redundant feature. But this is what it looks like, right? If you have a function that takes like 2 parameters, like if you pass 2 parameters, then it's valid. So if you just pass 1 parameter, this didn't fail before, but it will catch the error now. But if you pass 2 parameters and one of them is nil, well, the arity of the function is still 2, so that's valid, right? But who will write this, right? So, I mean, it's very like 80-20 thing. Like it's a very simple thing that catches like the kinds of mistakes that people actually do, right? So you kind of have to be forcing to get into trouble with that. So yeah, but if you want to be able to do that, then you actually mark the arity like not in the type but in the argument, right? Like the argument is optional. It's not that the type of y is like an optional integer. The type is integer, but y is an optional argument, right? So that's like a very simple to implement thing, like that I had it. I can draft state for a long time, and I just decided to put that into the language, because it's always like, oh, do I want to add one more feature to the language, right? Do I want to? Because I was able to do like, to write the Teal compiler in itself. So with the features that it currently has, you're able to write a compiler. So like, I go like, okay, the features look enough, right? But people keep asking for more features. So, but then like being possible and being pleasant is kind of different. I already feel like coding in Teal in general, because of the helps that type give you, already feels like more pleasant to me as in a very subjective way than coding in like plain Lua, right? But when I started working on the next feature, like then I really wanted to have this, because I wanted to do big refactors and change the numbers of arguments of things, and I wanted the compiler to tell me if I was making mistakes. So I added this feature for my own use, and it already proved like useful enough. And yeah. So if we're doing that for null safety for arguments, what about for table keys? Can we do that? It's trickier to pull that off, right? Because even if you want to say like, oh, this key is optional, this key is mandatory, one thing that people do in Lua all the time is just like start a table with like open close bracket, like this is an empty table, and start filling the elements one by one. So like after the table is ready, right, that argument is no longer optional, but it's optional for a while, and it's a very common pattern. So however, since I had a feature that I created for my own use of how I specify maps, I adopted that for records as well. So, which is that total annotation, because like Lua, like modern Lua has these annotations like const, and so I just added one to say total, which is for things like this, right? If you have an enum saying like, which essentially restricts your string type into a set of known strings, right? You can say that the map that you're declaring here is total. So the compiler will give you an error here because you specified north and south, but not east and west.
And the recording stops in 3 minutes.
Okay. So, right. So essentially we did the same for records, right? So you can specify a total record, and for that use case of I'm declaring a table and I want everything to be in it, you can specify that. Again, like it's a lighter weight solution than the whole solution, but it's something that already gives you, gets you a long way. Okay, so because we started late, right? How do we go on time? Like, do I just keep going and then?
We've got 2 minutes of recording. They automatically stop it. So
right. Okay. All right. So yeah. So then the second one, which is like the more interesting one, is like subtitle and table types. I mean, like, I have avoided going with like complicated subtyping definitions. As you start combining those kinds of features, like you can go real crazy with that. Like with even like features that programmers in typed languages use every day. Like if you combine like generics and subtyping, like there are computer science results that show you that you end up with like a computationally undecidable type system and things like that. So I have avoided like delving into this complexities for as long as I could. So for that super common case of I have this table which is a record and an array at the same time, I added this janky type that's array record that's just for doing that. And to avoid having to do subtyping and things like that, like and complex type hierarchies, just because I wanted to have collections, like I added like invariant generics, so you can have like list of T, but you cannot specify anything about T, and then that worked. And because typing in callbacks and passing like checking function arguments for covariance versus contravariant and all that gets complicated, you just do bivariant matching. You accept it both ways, which is like wrong, like it's unsound by design, right? But it will at least prevent you from matching like completely unrelated functions. Like you're not passing like the wrong function, but if you're doing the thing like in the correct ballpark, it will catch it, right? So yeah, which is some kind of like unsoundness by design that TypeScript already has to do. So yeah. And one big limitation that we had, because we had union types, but you could not have union types of multiple table types, right? Because at runtime, the code that it translates to, when you're trying to check like which value I have in this union type, which is like, oh, it's an integer or like my record, like my object. The Lua code that would generate became like Lua code that says like, so check that the Lua type is number or check that the Lua type is table, and then they couldn't tell all the tables apart at runtime, right? So you have to generate code that actually checks the tables by their contents, right? So you can tell like, is this a circle? Is this a triangle? Is this like, what is this, right? And it turns out that in the real world, Lua programmers like and existing Lua frameworks that people would want to use with Teal define their own object or OOP, like object-oriented systems, with their own like inheritance systems and how to declare like the type checking, right? People already do this, writing this custom code for type checking, right? But then the Teal compiler doesn't understand that, right? So for things like this, if I want to have the is operator to work nicely in Teal so that the compiler understands it, like I need to be able to translate that to that like framework-specific way of determining like what the type is, right? So since we had records before, like the next version of Teal is going to have interfaces, right? So the interface, like this was, like, instead of writing record, you write interface, right? But now you can actually have subtyping from interfaces which are abstract into records. But then you have this fine where clause here, which has an expression, like it has a bit of code which essentially is like, when you want to do an is check, this is the code that you should use. Like it's essentially a macro, right? You have to replace this everywhere you need to do that change, right? And now essentially you can do union types as long as all of the types that you're putting in the union declare like how to do the is operation, right? And yeah, we're running on time. So yeah, so that's essentially what I described there. And the thing is that magic where clause, right? Essentially, I had to add a feature to add a feature, right? Because like I'm really having to implement like a macro expansion thing for expressions just in order to have that where clause. So like, why not expose that? But then again, I thought like, oh, so I need to add macros to the language? No, I just went lighter weight again. I just added macros for expressions and not like a full macro processor, right? Which is what many projects for Lua have tried to do over the years, but none of them like have become established, right? And turns out that where now it's syntactic sugar, like we actually have like macro expressions in the language, right? But it was motivated by that, right? So in short, what happened? Like Teal has seen use, yay. People want more features and less limitations, which translates to many feature requests. Oh no, right? But many feature requests, they relate to the same pain points, right? So the idea is that you try to combine them and come up with like what's the most minimal design to try to address the most of these pain points. So the things that came up out of that were like optional arities, interfaces, macro expressions, and the idea was that I would just pick the lighter weight solution, right? Because whenever possible, right? Just to try to like just harking back to the title, like minimalism of the language versus its growth, right? Both the growth of the compiler, the growth of the language specification, and the growth of the user base, right? So so that's the approach that I took. Like you sometimes you have to choose like the incomplete solution just in order to balance all of those desires, right? So yeah, that's it. What I had. Thank you for sticking around.
Thank you, Hisham. We need to free up the room for the next round, but we can still have one or two quick questions. Quick, that is. Yeah, yeah.
So have you decided if you want to improve the solution for meta programming or improving some part for the meta tables and all that stuff?
Okay.
Have you decided for something for that or you plan to not go in that direction?
If I have some plan to improve the handling of meta tables, it currently does have support for meta tables in records. You can specify them. The checks are not very strict, right? And I haven't had much feedback on that. So, like, if people run into trouble, I look into it. Otherwise, I'm just going to keep it as it is. Right now, you can use them, and no one's complaining. So, I'm happy with that.